everyone, welcome back to the channel. I'm Manisha. So today in this video we are going to see multilayer perceptron neural network. It's a type of neural network. So let's see what we have in this video. So in this video first I'm going to explain what is MLP, multilayer perceptrons neural network, and then we will see its implementation using TensorFlow. So let's talk about the basics of MLP. Here is a simple overview of multilayer perceptron. So first, it is a type of neural network which is designed for the task like pattern recognition and making predictions. So what is a perceptron here? Perceptron is a type of simplest form of neural network, and it takes multiple inputs, applies weights to them, sum them up, and passes the result through an activation function to produce an output. So now we will see each component of the multilayer perceptron in detail. You can also refer these two papers to check multilayer perceptron or to study in detail. Starting with the basic structure, I would say there are two main types of components that I think it's important. It's node and the second one is layer. So node, each layer is made up of nodes or neurons, where each node is in one layer is connected to every node in the next layer. About layer, multi-layer perceptrons consist of three main layers: input layer, hidden layers can be more than one, and output layer. Input layer receives initial data and passes it to the hidden layers, and hidden layers perform computations on these data, transform it into various ways, and finally the output layer produces the final results based on the processed information from hidden layers. Talking about function of nodes, there are three main functions: weight, bias, activation function. Weight means each connection between nodes has an associated weights that can be adjusted as the network learns. About bias, each node has a bias term which is also adjusted during learning to help the model fit better. Activation function, each node applies a non-linear activation function to its inputs, which introduce the ability to capture non-linear relationships. Talking about activation functions, so mainly three activation functions: sigmoid, tanh, and ReLU. What is activation function? It is an important aspect in multilayer perceptron. It introduces non-linearity into the network, and this also allows a network to learn complex patterns and relationships in the data. And these are the types of commonly used activation functions in MLP. Next is about learning process. So forward propagation, loss function, backward propagation. So in forward propagation, what exactly happens? It takes inputs are passed through the network from input to output layer, and each layer's output calculated based on its weights, biases, and activation function. And what is the role of loss function? It compares the output of the network to the desired output and quantifying the error of the model. About backpropagation, it used to minimize the error of the neural network by adjusting its weights. So the really key goal or primary goal is to improve the accuracy of neural networks prediction. So next is about application MLP. So we can say the classification task, regression, feature learning, we can use MLP. So about classification, we can for example classifying email as a spam or not spam. It can be also be used for the image classification task. In regression, so we can take example like predicting continuous values such as weather forecasting or temperature forecasting. It can also used for natural language processing, text classification, so classifying document or sentence into categories like positive or negative. Can also say that sentiment analysis. There are many areas where we can implement MLP. In this video, the next thing that we are going to see is implementation of MLP. Now I'm going to open the Colab and we will see the rest of the things. So in here I have already created a notebook in Google Colab. So the first thing that we are going to do is to install TensorFlow library. Using this library, we are going to implement multilayer perceptron neural networks. I have also taken a data from Kaggle that we will see in a bit. So first let me install this library. After the installation, next is importing the important libraries that are needed for the analysis. So after this we are going to import the dataset. I have already taken this dataset from the Kaggle. There are two files, one is a documentation and the second one is a CSV file. So this CSV file I'm going to import using this code here, and we will see what is in the CSV. So these are the parameters or features that we have, and there is one variable that is target. So 0 and 1, so binary classification problem. 0 means without heart disease and 1 means with heart disease. You can also plot these variables and see their distributions using this utility here. So after this, DF data frame contains input as well as output. So we have to split into two different data frames. So we have to extract into X variable all the inputs, in Y variable our target variable. Using this code we can do that, and if you print you can see the input features here, and then next is Y, and then you can see the output variable. Okay, 0 and 1, just to make sure that what is the dimensions of X and Y, we are just going to print its shape. So we can see here 1190 rows and 11 features that we have in our data set, and this is target variable. So the next step that we are going to do is to create an X-train, Y-train and X-test, Y-test data set to train the model. So for that I'm going to use this code using train test a split function. We can able to get a X-train, Y-train and X-test, Y-test data set. So in this function I'm passing X and Y. I'm passing test size is equal to 20% and random state 24 and stratify is equal to Y, just to see if it is giving good results. So I also printed X-train here, so you can see it here. It's without target variable, and the dimensions of X-train, it is here. It has 80% of data and 20% data we can find in X-test data set. Now the next step we are going to do is scaling the features, and of course the features are in X-train and X-test, so we are just using scalar.fit transform function and we are passing these two sets here. We just want to scale X-train and X-test, not the output variable. We can check if what is the, after scaling, what would be the result, and this is the set that we have. Now it's a time to train the MLP model. In input layer we have 11 input features. In hidden layer 16 nodes I'm passing here with a ReLU activation function, and there is output layer which has a sigmoid activation function. So it is binary classification problem, and we are just forming a neural network with the 3 layers: input, output and one hidden layer. So I'm going to run this, and in the next step we have to specify the optimizer that we are going to use, and the loss function, binary cross entropy, and performance metrics. Here we are using accuracy. So we will run this, and after setting these few things, it's a time to train the model. So we are using X-train, Y-train to train the model. Epochs is equal to 100, and validation split, we want 20% of data to validate the model, and remaining 80% for training the model. And it's a very lightweighted models, and we already have the results. So I'm just going to print the result using this code. So here the accuracy, we can see that it's a 87%. And next is, if you want to see the predictions, so you can use a predict function on an X-test data set, and predicted and actual classes that you can see and you can print using this piece of code. That's all. It's a really simple implementation of MLP. You can implement according to your case study, and I hope this video it is useful. Thanks for watching the video. I hope you like this video. Please subscribe to the channel, leave your comments for me in the comment box, and take care and see you in the next video.